All right, so hello everyone. This is the first lecture on avionics. So in this first lecture, we are going to study about what do we mean by the word avionics and what are the advantages of using avionics system in an aircraft and some of the core avionics system, just in brief, just to introduce you. And finally, we are going to study about the steps that are followed or that need to be followed for designing a avionics system, right? So let's start with the avionics. What is basically avionics? Right? So the word avionics, it is a combination of two words, aviation and electronics, right? So basically in this module we are going to study about the electronics in an aircraft, right? So this word, it was first used in 1950s, long back, right? And since then, the avionic industry has developed quite a lot, right? So we are going to use this word avionics system or subsystem quite a lot in our further discussion or in our classes. So basically, avionics system or subsystem, they simply means that any system in the aircraft which is dependent on the electronics, right, for its operation is, or it can be categorized or called as avionic system. Although we are going to study some of the systems which will involve electromechanical parts as well, right? Even then, we are going to categorize them as avionics system or avionic subsystem. So in any system of the aircraft, if there is some part is electronic, we can call it as avionic system. Now, obviously, we all must be aware that avionic industry is a multi-dollar industry, and in most of the modern military or civil aircraft, the cost of avionic systems which are installed on the aircraft, it costs around 30% of the overall cost of the aircraft, right? And in high end or maybe some advanced version of the aircraft, something like maritime patrol or anti-submarine aircraft or even helicopters, right? They also highly rely or depend on these avionic system. So for such aircraft, the cost, it increases to 40%, right? So out of the total cost of the aircraft, you are, or the person is paying 40% just for the avionic systems which are installed in the aircraft. So you could imagine how big this industry is. And nowadays in AVAC system or in unmanned air vehicles or aircrafts, the cost is further higher, is more high. It's around 75% of the total cost, right? So you could imagine how big or how well developed or advancing this industry is. Now, why do we need avionic systems? Why do we need avionics in an aircraft? So initially, these avionic systems, they were installed in the aircraft to carry out aircraft missions safely and efficiently with less number of flight crew, right? So that was the initial need for developing your avionic system. Now, you might nowadays, basically in most of the civil aircraft, we only have like two flying crews, or you have only two pilots. One is the first pilot and or the captain, and the second pilot. So you have only two people flying the aircraft. But in older days, there used to be a crew member of four people. So you would have two pilots and a navigator and an aircraft engineer. So altogether there were four people who were flying the aircraft, right? But with the development of avionic systems, now the work of mostly the engineers and the navigator, it can be done by this avionics installed in the aircraft, right? So now only two or only the pilots, they can fly the aircraft without the help of uh, any other person. Now obviously in the aviation industry, we all know that if we can reduce the number of crew, right? If we can reduce the number of crew, we can carry more passengers, right? So the weight of the aircraft, or it means cost, right? It will have cost to carry that weight. So if we can reduce the weight, we can carry maybe more number of people or passengers in the aircraft, right? So it has a cost benefit. If you reduce the weight, it has a cost benefit for it. And in terms of military aircraft, it would mean you can carry more amount of payload, missiles or something. And also if you reduce the weight, it would also mean that you can fly for longer duration, right? Because you have to burn less fuel to carry that lighter weight. So obviously all these were the advantages which helped in developing this avionic industry. And we all can see that almost nowadays 70% or at least 40 to 50% of the cost of the aircraft is your avionics system. Now the avionics system are used to carry out aircraft missions safely. So what do we mean by mission? So in terms of civil aircraft, your mission is to carry passengers to their destination, right? In terms of military aircraft, it would mean either intercepting a hostile or enemy aircraft, or attacking the ground target, or maybe just patrolling or surveillance of the area, right? So that is what it means by mission, aircraft mission. Now coming on to the advantages of avionics systems. So obviously some of the advantages we have discussed just now, right? So along with those advantages, the avionics system, they have several other advantages, right? With the use of avionics system, obviously there is increased safety, or the safety of the aircraft is increased now, right? There are less number of accidents. The second advantage is aircraft traffic control requirements. So for ATC, now you can track the aircraft and you can manage all the aircraft, right? So air traffic controller, they can track and monitor the aircraft. All weather operation. So again, in older days, the aircraft could only fly in better visibility condition or in daytime. But nowadays, with the use of avionics systems like radar and night vision, you can operate the aircraft in all weather condition. and even in night time also, in dark also. Reduction in fuel consumption. Again, there are systems to monitor the the engine performance, and they also monitor the fuel consumption. So it optimizes, or it improves or reduces the fuel consumption as well. Improved aircraft performance. So obviously all these factors would definitely improve the performance of your aircraft. And the other advantage is better control and handling. So you have so many avionics system which something like cruise control and automatic landing system, right? So all those avionics system, they enable the pilot to control the aircraft in a better way. It is making the control of the aircraft much easier for the pilot, and reduced maintenance cost, right? So again, you have some avionic systems which monitor all the parts of the aircraft, and if it needs any kind of maintenance, it will give the specific requirement or the maintenance requirement to the maintenance engineer. So you don't have to, or the maintenance engineer does not have to look for the problem. It will be the avionics system gives the problem to him, that you need to replace this particular part, right? So the maintenance cost is also reduced, and the time is also reduced. Now, coming on to the next slide. So this picture in the slide, it kind of represents the core avionic systems, right? So the figure shows the primary or the core functions which are common to both military and civil aircraft. However, there are some parts or some avionic systems which are missing in this diagram, right? For example, you have ground proximity warning system. It is the system which sounds pull up when the aircraft is near the ground. So it gives a audible or a voice warning, right? So, or maybe your air traffic controller or ATC transponder system is another important part which is used in most of the aircrafts, right, which is not represented here. So although this picture, it represents most of the core avionics system, but some of the avionics systems, they are missing, they are not represented in this picture, right? But obviously this was the best one which I could find to give you an overview of the different avionics system. So I'm using it, right? So to start with the different core avionics systems, the first one, or the first few, are the ones which the pilot can see, or you can visually see them in the cockpit, right? So the first one is your display system. So obviously when you walk into a cockpit, you would see some display, lots of display basically, right? So displays, they provide visual interface, right? And they can be of three types. So you have head up display. So this picture is for head up display. So as you can see, like while looking for information, the pilot doesn't need to look down. It can, the pilot can keep his head up, and he or she will get access to all the information. So basically, this head-up display is a glass on which the information is projected. And the glass, it is transparent, so you can view the outside environment through this glass. So along with the information, you would have situational awareness as well. You can look around the aircraft. You don't need to look down. Right? So that's your head-up display, or in short, HUD. The second type of display is called as helmet mounted display. So this picture is for helmet mounted display. So in this display, the information is projected or displayed in the visor of the helmet. Okay, in this visor of the helmet. Right. So mostly it is used in helicopter where the pilot wears a helmet, or maybe in military aircraft. They are not quite common in civil aircraft. In civil aircraft, you use head-up display. Okay, and then you have head-down display. So these are your head-down display. So if you want to access any information, you have to look down into the displays. Okay, so we are going to study about them in detail in the future classes. The next type of avionics system is your communication system. So again, you would find some radio set in the cockpit, right, over which the pilot can communicate. So that can be also easily seen by the pilot, or it is visible. Right? So the communication system provide two-way communication between ground base and the aircraft, or between aircraft in the surrounding, between two aircrafts also. So the first avionics system was simply a radio transmitter and receiver. But nowadays we have several satellite communication as well. Right? So most of the aircraft, they are now fitted with GPS system and satellite communication systems as well. Okay. But in older days, we only used to have this radio communication only. The communication systems, they use different frequencies. So for long range communication, we use high frequency, somewhere around 2 to 30 megahertz. For medium range communication, we use very high frequency, or in short, we call it as VHF, right? Very high frequency communication, somewhere around 30 to 100 megahertz for medium range communication, maybe communicating with other aircrafts. Right? And for military aircraft, you have a dedicated frequency band. So they use ultra high frequency around 250 to 400 megahertz. Right? So again, we are going to study about the different communication system in detail in our future classes. The next type of avionics system is your data entry and control system. So obviously, to feed in the data, you would need some keypad, some touch panel, right, to get the information. So data entry and control system is essential for the crew to interact with the avionics system. Right? So some of the examples are keyboard, touchpad, and direct voice input are also being used. Maybe you can, the pilot, they can use some phrases or some words as an input. But Obviously everyone, they have a different maybe accent, voice, so they are not very common direct voice input, but yes, such type of system is also available, right? And voice warning system are also there. So with along with the visual display, you would also hear some voice or some warning, right? So something like the example I was giving, pull up, pull up. So that sound or voice warning system, that is given by voice warning system. Right. The next avionic system is your uh, core avionic system. Is your flight control system. Right. And they use the electronic system in two areas: auto stabilization system and fly-by-wire control system. So auto stabilization systems such as your uh, roll auto stabilization system, which damps or suppress the motion about the yaw axis and the roll axis of the aircraft. Right? And similarly, you have pitch auto stabilizer system, which suppresses the short periodic motion between the pitch axis. So basically these two subsystems are used to stabilize the aircraft in flight or in air, right? So that it doesn't topple or it doesn't uh, moves, right? To provide a better control of the aircraft. So generally, in most of the aircraft, you would need both or control over all the three axes, right, for better stabilization. Then you have fly-by-wire control system, which provides continuous automatic stabilization of the aircraft. And they use some motion sensor to stabilize, right? So they, with the help of several sensors which are installed in the aircraft, you maintain or automatically the aircraft is stabilized or its stability is maintained. The next type of avionic system, they are called as aircraft state sensor, right? So these are used for the control and navigation of the aircraft. So like in the previous slide, I was just mentioning that with the help of some sensors, right, you would maintain or stabilize the aircraft in the air. Along with those sensors, you would also need some air data. Maybe what is the wind speed, right? What is the pressure being exerted on the aircraft, right? So all those information, they are collected by air data system, or again you have a separate set of sensors which collect those information. And these air data, they can be used to calculate the altitude, the airspeed, the vertical speed, and usually in the military aircraft which fly at a speed around the speed of sound. So you can even calculate the Mach number or Mach speed of the aircraft. Right? So again, with the help of aircraft state sensor, you can calculate these values. Okay. Hopefully in the last unit, the last unit is on air data indicators. So in that unit, we are going to study about all these different indicators, altimeter and all, right? So we will study the working principle, how with the help of pressure sensors, temperature sensor, how we can calculate the altitude, the airspeed, and the Mach number of the aircraft. So in this aircraft state sensor, you have several subsystems. So one of the subsystem is your air data system, so which is essentially a computer connected to different sensors, right? So it collects the information from the sensors, process it, and provide the air data information. Again, as I mentioned, it will give you the temperature, the atmospheric pressure, and all those information about the air, or it will give you that information about your surrounding of the aircraft. Okay. And obviously they can be used to calculate the altitude, the speed, and the Mach number. The next subsystem is your inertial sensor system. So these inertial sensor system, they provide the aircraft altitude and direction in which it is heading, right? And basically these sensor, they are your gyroscope and accelerometer. Those are called as your inertial sensors, right? So with the help of these inertial sensors, your gyroscope and accelerometer, you can identify the location of the aircraft, right? So in the future classes, we are going to study about inertial navigation system, right? So the benefit of this navigation system is that it is independent, right? It can work on its own. It doesn't need any like GPS system or like that, right? It can individually give the location or the position of the aircraft with the help of the inertial sensor, your gyroscope and accelerometer, right? So gyroscope, it gives information about the angle at which the aircraft is flying, and accelerometer, it will give the speed of the aircraft. So if you know your reference point, so like if your aircraft is flying from Beijing, right, and it is flying at this angle and at this speed, right, at 30-degree angle and maybe 100 knots, right? So you can identify that after 1 hour of flight, this will be the location, roundabout or approximately this will be the location of my flight, right? So since it does not depend on any other system, it works independently, so it is quite useful just in case if your GPS system or your satellite navigation, it is not working, right? So you can use the inertial navigation system. Okay, so coming on to the next avionics system, which is your navigation system. So navigation system, it provides information, navigation information, such as your aircraft's position, ground speed, and tracking angle, right? So it gives all these three informations. The first type of navigation system is your position fixed system or radio navigation system, right? And they use radio signals from either from the ground station or from the satellite transmitters, right, to navigate the aircraft, right? Now, generally also, like if you are looking for a place, maybe a restaurant near your location, so there are two options. Either you will ask someone that where is that particular restaurant, or you would simply, if you have an idea, you would continue moving in that direction and maybe estimate that after like 5 minutes I should reach the restaurant or that place, right? So if you are asking someone, that is similar to your radio navigation. So you have GPS systems, or you have ATCs, air traffic control systems, and also you have VOR systems as well, so which provides the exact location of the aircraft, right, through radio communication. It will tell you that this is the exact location of your aircraft. The next type of avionics system is your dead reckoning system, or in short we call it as DR navigation system, right? So this is the second type of navigation where you will continue to move in a particular direction and you can estimate your location, right? So one of the navigation system which we have just now discussed is your inertial navigation system. So with the help of some sensors, basically a gyroscope and accelerometer, you can estimate, or you can find the location of your aircraft. The second type of DR navigation is your Doppler or heading reference system, which are usually used in helicopters. And then you have air data and heading reference. So heading reference is obviously, if you know your heading reference and if you know the speed of the aircraft, so the air data will give you the speed of the aircraft and all those information. So again, you can estimate the location or the position of your aircraft. But the third option, or your air data and heading reference, it has very low accuracy. Okay. The best one is your inertial navigation system. It has the highest amount of accuracy. The next type of avionics system, they are your external world sensor system, right? And they basically comprises of your infrared sensors and your radar, which allow the aircraft to fly in different weather conditions and even in night time. Okay, even in dark also the flights or the aircraft can fly. So the infrared sensors, obviously I think you all must be aware about the infrared sensors, what they are used for. So basically they provide thermal image of the outside world. Image something similar to this one. So basically your infrared system, they capture the heat source, right? And they like represent it by a different shade of gray, something like silver, right? So the pilot can identify the object even in dark or in night time also, right? So generally we use forward-looking infrared sensors for this, or sometimes we use gimbaled infrared image sensor to get this type of image in the dark, and they are generally used in military aircrafts, mostly in helicopters and even in like fighter aircrafts as well, to get a clear picture in the dark. Okay. And the next subsystem is your radar system. So obviously we all know what is a radar. In brief, we all know that they could be used to determine the weather condition. So radar system, they provide weather data or weather information, right? Whether it is cloudy or what is the condition in front of the aircraft, right? If it is going to go through some clouds or maybe some bad weather condition, so the radar system will provide the information or the warning to the pilot, right? So generally we use multi-mode radar in the aircrafts, and along with the weather information or weather condition, these multi-mode radar, they can be used to uh, detect targets up to like 12 number of targets, right? In the case of military aircraft, you would also need to track different aircrafts or maybe some hostile or enemy aircraft which are coming in. So with the help of radar system, this multi-mode radar, they can track up to 12 aircraft simultaneously, and they can track the target or those hostile aircraft up to 100 miles away from the aircraft, right? So we use this radar system for two purposes. One is your weather condition, and the second is for tracking, right? Tracking different aircrafts. Now the last avionics system is called as your task automatic systems, and they are basically used to reduce the workload of the crew. Okay, so you can operate the aircraft with minimum crew. Okay, there are some subsystems. So the first subsystem is your housekeeping management, right? They basically automate the background tasks which are essential for safe and efficient operation of the aircraft. So for example, you have fuel management system, electrical power management system, then hydraulic power systems, and cabin pressure or cockpit pressure system, which controls the uh, pressurization of the cockpit. And then you have environmental control system, which maintains the temperature and humidity within the cockpit, or even in civil aircraft also they are used. Then you have some warning system, right? So this would include both the visual warning, maybe flashing of light, and the voice warning, right, as well, the sound as well, and the maintenance and monitoring system. So all these subsystems, they are included in this housekeeping management system, which kind of monitor the overall working or the performance of the aircraft. Then you have navigation management system. So in the previous slide, we have discussed different navigation systems, right? So the information from all those different sources, they are combined by the navigation management system, and it will process, basically it will be a computer, it will process all the navigation information from different navigation systems, and it will process or combine all the data to provide best estimate of the aircraft position and ground speed. Okay, so from different sources it will collect the navigation, process it, and provide the best estimate of the aircraft position. Then You have autopilot system, which is quite common in most of the commercial aircraft. So this autopilot system, basically they can be operated in various modes. You would have height hold. You can operate the autopilot system in height hold mode. So it will maintain the altitude of the aircraft, right? Then you can also operate in heading hold. So it will, if it is flying at a particular heading, it will continue to fly in that heading, right? So basically autopilot, they can be operated in these two modes, and also they can assist the aircraft in automatic landing. So while the aircraft is landing, that can be also done automatically with the help of this autopilot avionics system. Okay, and then along with that you have flight management system, or in short we call them as FMS, right? Flight management system. And basically the flight management system, it reduces the work of the pilot significantly. So it will do the flight planning. So if the pilot just enters the GPS coordinates of its destination, the FMS system will give the best path which the flight can follow, and it will also give information on the fuel the aircraft should carry to reach its destination. So all those information will be calculated, or it will be given by this FMS system. It will also provide navigation information. Again, it will also provide, or it will control or maintain the engine. So during the flight, it will control the flow of the fuel, or it will minimize the fuel consumption. So basically, when the flight takes off, it is heavy because the tanks, they are full. You have fuel, it is carrying the most amount of weight. But as it approaches the destination, or as it flies towards the destination, it will burn the fuel, right? And when it approaches the destination, the aircraft is lighter. So if the aircraft is light in weight, so it would need less amount of fuel while landing, right? So that is controlled by your FMS system. So it will keep on tracking the weight of the aircraft, and it will accordingly adjust the fuel consumption, right? So obviously that will make the flight or the aircraft more efficient. And it ensures, the FMS system, it will ensure that the aircraft is at the scheduled 3D position, right? So it will ensure that the aircraft is at planned 3D position at the planned time slot. So for air traffic control, or nowadays with with the increase in air traffic, these it is quite necessary to know the exact location and plan the flight, right? So it is essential for the air traffic control system as well. The last avionic system is your full authority digital engine control system. So which controls the flow of fuel to the engine. It ensures that the engine temperature, the speed and acceleration is in control, right? It monitors the engine, and it also is used for engine health monitoring, right? So it will record the deterioration or any excess wear and tear in the engine, and inform the pilot if there is a warning, or it will also inform the maintenance engineer as well, right? So it keeps a track of the engine, and it will monitor the health of the engine, and it will provide the warning to the pilot or to the maintenance engineer. Now, to design an avionics system, the first thing is, or the starting point is, a clear understanding of the mission requirement. Right? What is the purpose of designing that avionic system? Right? So once that understanding is there, then there are three stages in which avionic systems they are designed. The first stage is your conceptual design. So in which the design engineer, it will answer some of these questions, that what that avionic system will do, how it will do, and what is the general arrangement of the part. So generally the end result is a clay model or a sketch, something like this. After the first step, you should have that conceptual design in form of a sketch or a model. The next stage of designing an avionics system is your preliminary design. So in this stage, you have to consider that how big it is going to be, or you have to consider all the details of the individual part, like how big it is going to be, what will be the weight, how much it is going to cost, right? So all that analysis is done. So generally the end result is a spreadsheet. So generally this preliminary design analysis is done on a spreadsheet. So you will kind of estimate the weight, the size of the avionics system, and how much fuel it may consume, or what will be the cost of that avionics system. After you have done this analysis, the next step, or the next stage before fabricating the avionics system, is your detailed design stage. So in this, generally we develop a model or a simulation model, right? And in the software, we test that model, whether how many parts it will have, what are the material which we could use to fabricate that avionics system. So something like if you are designing an avionics system or any part for a military aircraft, right, which flies at very high speed. They are designed to fly at Mach speed, or the speed of sound, right? So if you are designing any equipment for military aircraft, you should consider that the aircraft would or could fly at very high speed. So whether the material which you are using, will it be able to withstand that amount of pressure or drag when the aircraft is flying at that high speed, right? So you have to consider all those factors in the detailed design part. Now finally, along with those design steps which I have mentioned, basically 3 steps, we also need to consider some of the elites which the avionics system should have. So elite, basically it means the quality the avionics system should exhibit, or it should present, right? So these are the qualities, some of the qualities which an avionic system should have, right? It should be obviously reliable, right? It should be maintainable. That is, if that avionic system uh, stops working, you should be able to maintain it or repair it. Then there is certification. So generally all the aviation or avionic systems, they are certified by some authorities, right? So if while designing the avionic system, we should also consider that whether it is going to pass the certification or not. Then in the case of military aircraft, you should also the avionic system should also be considering survivability, that in the adverse condition or in very high speed or in such adverse condition, whether my avionic system is going to survive or not. Okay. Availability obviously is quite important. So if you have to replace the avionic system, it should be easily available. Then you have life cycle cost in military or cost of ownership. So while designing an avionic system, you should also consider that maybe you have that concept of designing a very high-end avionic system, very sophisticated avionic system, but you should also consider the cost of ownership. If that avionic system requires continuous maintenance, or if it requires replacement after a very short period, then it is going to cost a lot for the company, right? So that is your cost of ownership. So we should also consider this while designing. And obviously technical risk, no sparking, no fire, right? All those, or it should provide the accurate information. So such type of technical risk should not be there in your avionic system. And obviously the weight and the power consumption. So in aviation, weight means money, right? If you can reduce the weight, you can carry more passengers, and obviously the company can earn more money. And similarly, the power consumption. So again, the avionic system which we are designing, it should consume less power, right? So you have to burn less fuel to provide or operate that avionic system, right? So these avionic systems, these elites or the quality of avionic system, they are described in the class notes which I have provided. You can go through them after the class, and this should be the end of the first lecture.